So part 176 is line 18A, 3z5b3a, nuclear fusion, collision, spin, polarized plasmas, electron heating, velocity, 5G Wow Seti. There's our Wow Seti radio signal. That's the equation. There's the answer to it. So we Google the number, and this is the data that comes up from it. Nuclear fusion volume 26, number 11, create an alert, RSS this journal, R.M. Coulomb, 1986. Physics of spin polarized plasmas from R.M. Coulomb, E.J. Vallejo, and S.C. Cowley. So this is obviously some sort of PDF that came up. If the nuclear spins in a fusion reactor are oriented or polarized in an appropriate manner, then the nuclear reactions are modified in such a way as to enhance the performance of the reactor. The methods by which the spins can be polarized and the various difficulties connected with these methods are discussed. The processes by which the polarization can be lost owing to various physical processes in a confined plasma are assessed. The different polarization modes of the plasma ions are applicable to the different nuclear reactions DT, D3H, and D to D. The benefits for reactor performance of these modes are discussed. It is concluded that on the basis of current knowledge, the possibility of achieving polarized spin in a fusion plasma cannot be ruled out, and that the physics of such plasma is well worth pursuing both for its intrinsic interest and for its benefit to fusion. Further detailed calculations of the modification of the DT nuclear reaction produced by spin polarization are given, as well as calculations of the depolarization rates for physical processes in a confined plasma. Finally, a kinetic description of a polarized plasma is outlined, which generalizes the normal kinetic description of a plasma. And these are all the things that are discussed in this article. Electric and magnetic measurements, transport properties, 2H induced reactions, plasma kinetic equations, fusion products effects, alpha particles, fast particles effects. And the subjects are nuclear physics, instrumentation, and measurement. Okay? That was from November 1986, 1984. The next one that comes up is called Velocity Distribution Functions and Reactivity of DT Fusion Plasma with Spin Polarized Fuel from Toshiki Takahashi and Yakusuke Nakao. Department of Electronic Engineering, Gunma, and University Kairu, Gunma, Japan. And it's from ScienceDirect.com. So velocity distribution functions and the reactivity are calculated for DT fusion plasma with spin polarized fuel. The distribution functions are classified by spin states. Binary collisions and the resonance with waves are taken into account as a depolarization mechanism in plasmas. Spin orbit interactions are shown to have no deleterious effect. However, lower hybrid heating and current drive using GHZ waves resonant with the spin precession frequency are found to cause complete depolarization when the ratio of the amplitude of the fluctuating magnetic field to the external field exceeds 10⁻⁵. Thus, electron heating may increase the retention of polarization. Other depolarization mechanisms in plasmas will also be discussed. Okay, and there's the keywords. That's from ScienceDirect.com. Here's a graph. It's hard to see it. Distribution function for deuterons. This is distribution functions for tritons. And this is polarization for deuteron and tritron and alignment for deuteron in case of the external field. That quote. Whatever you call it. I haven't done this for a while. Okay, so the next one's production of polarized particles in nuclear reactions. This is a PDF that comes up. And it's from A. Simon and T.A. Welton from the Oak Ridge National Laboratory from Tennessee. See also Eratum. Received March 4th, 1953. So this is an oldie one. So general calculation of the polarization resulting from nuclear reactions is made by means of the S matrix and Racah formalisms. All sums over magnetic quantum numbers are performed, and the resulting polarization is expressed as a series in associated Legendre polynomials, each coefficient being manifestly real. All selection rules follow immediately from the requirements for the non-vanishing of the Racah and X coefficients. The only restriction required is to a two-body breakup. Higher spin tensor moments are required for the complete specification of the state of polarization of a beam of particles of spin greater than a half. So you got to remember, this is going to be important for the laser beam that they're going to use with the neutrinos to speed up in the liquid argon gas, which is a fuel mixture for a jet propulsion engine for a UFO type ship. Okay. I call it a UFO engine because it's going to be faster than anything that man has ever made, according to this alien technology that's coming up. What it's doing is taking bits and pieces of things that you guys have actually created yourselves, but you don't know what to use it for, and we're putting it together like a puzzle piece to see if we put it together, if it will create this type of engine that we need so we can travel further than the Milky Way galaxy over to the Kepler region, or the Kepler solar system. Okay, that's what this is all about. But anyways, we'll go back to the notes here. It says the specification of the state of polarization of a beam of particles of spin greater than half. So a general expression is given for arbitrary spin moments resulting from a nuclear reaction. The result is expressed as a series in the spherical harmonics with all coefficients being manifestly real. The previous results of Blatt and Beinhard for the angular distribution follow as a special case of the result. A generalization of the Eisner-Sachs rules for the complexity of angular distributions is also given. Again, this is an article from 1953. This came up in the Wow Seti signal. Okay, so April 7th. You can tell when I started working on this stuff. I took a break for a couple weeks there. For 3 weeks, I wrote a novel and I wrote a screenplay. So I've been busy. So anyways, April 7, 2012, my thoughts. Some keywords come up on this section are plasma plus kinetic energy plus nuclear fusion. Okay, those are keywords that come up in a lot of the videos from 1 to 180, or 1, whatever number we're on here. Well, I'm filming 176, but I've got over 180 videos ready to go. So plasma plus kinetic energy plus nuclear fusion. April 7, 2012, 4 minutes later. Reading over the research from production of polarized particles in nuclear reactions. We're going to continue the rest of the keywords on lines 18A, and this is where I started dividing it up into 2 modules, and of course it's worked out to 8 altogether. So as you can see, again, there's all the name of the videos. You want to start with this video first, line 18A, 3z5b. That's the first one. And then you're going to go all the way up to line 18A, 3z5b6. Okay? And again, there's the tags, which I just did in the last video. I'm not going to... Well, this one has a few more because it's got more stuff from all the videos. Okay? So we'll go on to the next one.